Hey guys, so this is reverse sort engineering problem C of Codejam 2021. This problem was worth 7 and 11 points. So for two of the cases, which is the first case and the second case, two tests I mean. So this problem is actually a reverse engineering problem. Actually, it is the same problem as reverse sort but in the reverse manner. It's actually a very interesting problem to see. So what did reverse sort algorithm problem do? So actually I have covered how to solve the reverse sort problem in a previous video, and it's a really straightforward problem. Like reverse sort was really straightforward that you can do it with brute force, but the reverse sort engineering is not like little straightforward. You have to think a little bit more. So what does reverse sort do? In reverse sort you are given an integer n and you have an array that is from 1 to n containing elements from 1 to n distinct elements, and what we have to do is that we have to use this reverse sort algorithm to sort that array. So while sorting that array, what we do is that we find the minimum element. We take an element I, position I, from 1 to n minus 1, and then we find the position j, which is the minimum position of the minimum element between I and length L, and then we reverse that section I to j. So that was a fairly straightforward process, and we are asked to find the cost associated with that process, which is given by this formula j minus I plus 1, which is directly from which we can directly apply to this pseudocode. But here we are given the cost, and we have to generate an array that will result in that cost. That will give us that cost after we do this operation. So it's actually the direct reverse of this question. So let us see, we are given a 100 test case, and C, which is the cost of the array. Cost, you have to make the cost. We can make an array which results in this cost, which is a maximum at 1000, and we have a test case with n less than 7 and n less than or equal to 100. So the most important thing we have to make sure is that there is a distinct integer between 1 and n. Each of the element of y has distinct integer between 1 and n. So yeah, let's see that we can also see that the sample test cases, and we see that there are impossible cases, and in impossible case we have to print impossible. So there are impossible and possible cases, so that's a hint. So what we have to find is that we have to find a boundary where the cases will be possible and impossible. So for 2000 it's impossible, which is 2 is the size of the array and 1000 is the cost which you have to make, it's impossible. And for 7 and 2 it's also impossible. I mean, from 7 means it's actually distinct integers from 1 to 7. That's 1 2 3 4 5 6 7. So according to my thinking, my first task was to find the boundary. So what is the minimum possible cost that you can perform with an array of size n? So let us move to this. So for that I tried an example like 1 2 3 and 4. As you can see, this array is already sorted. So what is the minimum cost here? What is the cost here? You can see is that 1 will take this is a minimum element itself, so it will have cost 1. We know that the cost formula is j minus I plus 1. So we are reversing itself. So there is no meaning reversing itself, like j and I are same. For j minus I is 0 and then 1. So the cost will be 1. So the next step we get to 2 and the cost will be 1 again because it is the minimum element. And then we get to 3, and 3 is again the minimum element that we get to cost 1. So the total cost here we can say is the total cost is actually 3. So what does this mean? This is the minimum cost. So how does this become the minimum cost? Because any other permutation of this combination, any other permutation will cause an additional reverse or additional reverse to actually have, because this is the sorted order. So in order to make any other element configuration or any other permutation to the sorted order, we have to make another reverse which will result in a number cost greater than 3. So for example it was 2 1 3 and 4. So if it was 2 1 3 and 4, we had to make a swap to bring 1 to the front. So so first it is 2 and new element was 1, so we will make a reverse of this entire section, that is 1 2 3 and 4. So this will result in a cost of 2 plus 2, it is j minus I plus 1, it is result in a cost of plus 2. And then we go to 2, that will result in a cost of 1, and then we move to 3, that will also result in a cost of 1. So here the total cost resulted is 4 actually, not 3. So it, in any case it will not be less than 3. The minimum will be 3, and that minimum will go to the sorted, completely sorted array. So what we are going to do is that we have the minimum limit, that is 1 2 3 4. Minimum is for the completely sorted array and it's actually 3. So for 5 it will be 1 2 3 4 5. The minimum value would be 1 here, 1 here, 1 here, 1 here. It would actually be 4. So the minimum will actually be n minus 1. So the minimum is equal to n minus 1. So we have one condition here. So our one condition will be minimum is equal to n minus 1. So here we can say is that n is 7 and c is 2. So the minimum can be n minus 1, which is 6, but it is 2. 2 is really less than 6, so we can say that is impossible. So we already solved one impossible case in the sample test input. So what we are going to do is that then we are going to add a next case, like what is the maximum, how can we do the maximum of these cost. So suppose we can find that 1 2 3 4 is the minimum case. The maximum would be 1 2 3 and 4. So why is this the maximum case? This is the maximum case because in each and every step we have to do a swap, and the swap's distance is the furthest in each case. Let us see that. How did I get this configuration? Let us see. Like in the first case, you can see that 2 4 3 1. In the first case we have 2, and then the minimum elements position is at here. The minimum element is 1. So we are swapping this entire array. That is actually 1 3 4 and 2. So the next section we move to 3, and then we can find that the minimum element is 2 here. That's because we swap the 2 to the last position. So the minimum element is 2 here. So the swap distance actually is the greatest distance. It's actually the last element. Minimum element is the last element. So we find 1 2 4 3. Again we move to 4 and we find that 3 is the minimum element, and then we again swap it 1 2 3, swap reverse this entire section 1 2 3 4. So as you can find that by this array, like by this permutation, we can see that after each reversing, the minimum element of the next section that we have to check actually resides in the last place. So the trick is to actually use this sequence 1 2 3 and 4. So some of you might be thinking like, how did I get this sequence? So the way I got this sequence was pretty similar. So what I did was took the first question, that is the first question of the Codejam, and then I checked some permutations, and I did a function to write all the permutations of this 1 2 3 4, and then I checked the cost of it and found that this was the maximum cost. This permutation, that is 2 4 3 1, was the maximum cost. So if you really don't know the answer for a question, what you have to do is that you have to make some program to brute force the answer for you, and then check some way to make the answer more efficient. So what I did was, this question will result in actually this question was resulted in actually this was the maximum one, and let us see what is the cost of this. The cost of the first step was 4 actually. Cost of first step was 4. In the second step the cost was actually 3. As you can see, the 3, this 3 is actually 3 minus, it's actually 4 minus 2 plus 1, it's actually 3. And in the third step it was 2. So in this last step there's no cost. Step terminates here. So what is the total cost? Total cost is 4 plus 3 plus 2. What is it? It's actually 9. So if you take the case for 5, like 1, 2, 3, 4, 5, this would be the minimum minimum cost permutation, and the maximum cost permutation will be 1, 2, 3, 4, and 5. This would be the maximum cost permutation. So what would be the minimum cost value? Minimum cost value would be actually n minus 1, which is actually here it would be n minus 1, which is actually 4. So what is the maximum cost permutation of this? For this case it would be 5, because in the first swap it would have 5, in the second swap it will have 4, which is this, in the third swap it will have 3. You can see get the pattern, right? Like in the fourth swap it will have 2, it will not have 1, because in the fourth swap is 6 and it only have 2. The fourth swap, in the fourth swap it will have 2. So this is the formula. So what you can say is that it's actually 10 and 14. 14 is the maximum value for 5, maximum cost for 5. So how can we find this? So as you know that there is a formula for sum of n elements, that is 1 plus 2 plus 3 etc. up to n is equal to n into n plus 1 by 2. So what we want is that actually 2 plus 3, we don't want this one, we are not adding 1. So what we do is that we subtract 1 from here. So our formula actually becomes n into n plus 1 by 2 minus 1. So this is our maximum case. So this is our max value. So what you have to do is that our cost C should actually be greater than or equal to n minus 1, and it should be less than or equal to n into n plus 1 by 2 minus 1. So this is our condition, this is our important condition for actually finding that whether our case is possible or impossible. So that's our technique. So as you can see that these two cases, that is a 2 7 7 7 2, this actually fails this case and minus 1 case, and then you can say is that 2 and 1000 actually fails what this case. 1000 is greater than n plus 1 by 2 minus 1 for n equal to 2, actually this n is equal to 2 actually. So it's an impossible case. So we got the possibility and impossible case. Possibility, we actually found the possibility. Now the problem lies whether how to find the array when it is possible. So well, here given a cost of 6 and we have to find the array 4213. How can we find that? So let us move to the next step. So here what we are doing is that let us consider this minimum cost, that is 1, 2, 3, 4 and 5. As you can see 1, 2, 3, 4, 5 is the minimum, and test or let us take 1, 2, 3, 4. 1, 2, 3, 4 is the minimum, and it has actually 3. Minimum cost is actually 3. So I'm going to actually write cost here. So actually it is cost, minimum cost is actually 3. It's a minimum cost. So next we to make something with cost 4, we have to make one additional swap somehow. So how will I make that swap? So let us swap these two elements. What you get is 1, 2, 4 and 3. 1, 2, 4 and 3. So with this what we can say is that the cost is 4 actually. You can see that this will cost 1, this will cost 1, cost will be 1. Like I am saying the contribution of each cost actually. So this will actually cost plus 1 while reverse sort. So this is the minimum element in this section, so it will cost 1. So this is not the minimum element is 3. So this will cause a cost of 2. So as you can see, it is 1 plus 1 plus 2. It is actually 4. So by swapping certain elements, we can actually increase the cost from 3 to 4, something like that. So as you can see that the maximum cost which you can reach is actually 1, 2, 3 and 4. So the trick is actually to reach this maximum cost somehow from this. Trick is to reach this maximum cost from the minimum cost array. So to reach the maximum cost, we want to fix the 1 at this location. So somehow you have to bring 1 to this location. So once the 1 reaches this location, you should not change it because it is a maximum case. And we have to bring 2 to this location. And once 2 is brought to this location, you should not change the 2 because 2 is the correct position for it. And then after we have to bring 4 to this location and 3 to this location. So we can directly bring it. We have to bring it by incrementing this step. Like after through bringing it, in each step we have to increase this cost by only one. So we can directly bring it. So that's the method which I'm going to follow. So we have to listen carefully in this part because it's a kind of bit tricky and implementation is also tricky. So in this, what we are going to do is that we are going to create 2 pointers called as front and then another pointer called as k or back. So actually I did with k back. So the front pointer is pointing to here and the back pointer is pointing to here. So you can know that the minimum cost is actually n minus 1, which is actually 3. And then what we are going to do is that within each we got something known as a reference array. We will talk about what is a reference array later. So this is our, let us be our original array, this 1 2 3 4. So with each iteration, with each step, in order to make this cost 1, we swap this section of the code. So in this first thing we swap 1 2 4 and 3. We swap this because in this swap we get an additional 2 bonus and then the cost will be 4. And then for making the cost 5, if you can guess, we will swap this section. Why we swap this section is because by swapping this section we get a bonus of 3, and then we get an additional 2 bonus which actually results in a 5. So if we swap this section, reverse this section, that is actually taking, we are reversing this section means we are referencing to this array. We get 4 3 2 1 4 3 2. 1 4 3 2 will have cost of 5. If you want to check if it has cost of 5, we can check. Actually it is cost 5. You can see that is 1, it will cost a plus 1 cost. 4 will cost a plus 2 cost. Plus 2 cost, and the array will become actually 1 2 3 and 4. So it will be a plus 1 plus 2 cost here, and then for 3 it will be a plus 1 cost. For 3 it will be a plus 1 cost. For 4 there will be plus 3 cost. That was the confusing. For 4 will be 3 plus 3 cost, and then for 3 there will be plus 1 cost because it's actually j minus I plus 1. So the total cost will be 5. So that is what the trick was about. So let us continue with our next permutation. That is, what is the cost is 6. For cost 6, as you have guessed it right, we have to swap this entire section, which means to swap the entire array. Like that means that is actually 4 3 2 and 1. So this will result in a cost of 6. So as you can see, we have swapped this entire array. So we need to say that we have find that we have made this 1 here. So that's our first step. Like we know that the maximum array starts from 1 2 3 and 4. So we reached 1 here. So when we reach 1, what we do is that we decrement k. So what we do is that the k, it's the pointer, points to this position. Right? And now this is our array. Now our array section is actually this one. It's actually this one. like we don't point to 1 because 1 is already fixed and 1 is done. So we check this part of the array. So when we check this part of the array means this is our array and our k pointer is this and our f pointer is pointing to this, and we check this portion of the array, and we repeat the same process on this portion of the array. So let us see how that is done. So why I use a reference array is that we need to copy this array and then update s. So that's why I use a reference array. There is no need for reference array, but it comes in handy to make the things much more easier. So what we do is that the next step is 4, 3, 2, and then 1. This was the array. So we are not taking care of this one. This is our part now. So what we are doing is that we are actually swapping this section. We are actually swapping this section. So when we swap this section, we get 4, 2, 3, 1. So this is actually our seventh cost. Here it is the cost. Here is the cost. We are actually swapping the 7th cost. Then we actually swap this entire section. So we get 2, 3, 4, 1. So this is actually, as you guessed it right, it's actually 8th section. But the problem here is that we have reached the 2. That is, as I said, like we have to check for this continuously. We are doing 1, 2, 3, and 4, and we have reached the 2 of the maximum keys. So if we have to check both the front and back pointers, and for the front pointer, as you can see, we have reached 2. The back pointer is still not correct. So the back pointer has to be 3 here. The back pointer is 4. This we don't need to care about it, but the front pointer is 2. So what you have to do is that we have to increment the front pointer, which means f has to be incremented by 1. So our array becomes actually this one. So we again cut shorted our array to this portion. So we are going to repeat the same process for this portion of the array, leaving 1 and 2 as it is. We don't care about it because the front pointer is pointing to this and the back pointer is actually pointing to this. So what we do is that 2, 3, 4, 1. We swap these two elements and we get 2. There's no need for these two elements. As I said, these two elements are actually left out and the array is actually this now. It's actually this. It's like a recursive algorithm, but the array is changing actually. So we are doing 4 and 3 and 1. We swap this, and this is our 9th keys. As you can see that here the front and back pointers collide because the front pointer is 4 actually matches the front pointer in the maximum case. So just by referencing to the maximum case, we actually found all the cases from 3, 4, 5, 6, 3 to 9. So that's the trick. So what you have to find is that we have to find the maximum case and the minimum case, and we could make all the elements in array. So this is the basic logic in this question. So what I did was, so whenever I was asked to find a particular cost, so I made an array. So for example, if I am given an n is equal to 7 and I am asked to find a cost, I am asked to find a something array with cost, actually something like 10 or something, 10. So what I did was I just made an array like 1, 2, 3, 4, 5, 6, 7, and then perform the same operations on this array till I reach the cost of 10. That is the minimum, starting from the minimum cost, which is 6. So before that I also checked for the impossible cases. So that's how I did this question. So interestingly, this will fall in the time limit. It will not go beyond the time limit. It's actually not that big of a deal because as you can see, n is actually less than 100. So we also know the maximum cost. Also, maximum cost is 100 into 100 plus 1 by 2 minus 1. It's actually not just a big number for a 10-second test case. So yeah, that's how I did it. So let's move on to the code. So for saying the before the code, before saying the code, what you can say is that I have two variables. I'm going to discuss the variables. It's actually n and c, which is the number of size of the array, and c is the cost. And then I have found the maximum value, which is maximum value is n into n plus 1 by 2, which I have actually discussed in this thing. That's the maximum value is n into n plus 1 by 2 minus 1, and the minimum value is n into n minus 1. The minimum value is n minus 1. So I also got the minimum value n minus 1. So if c is greater than maximum value, or if c is less than the minimum value, I would say that the test case is impossible, because it is not possible to make such a cost. So then I had two array, that is the S and array, where array is actually a reference array, which I mentioned above, So why I needed a reference array? Asked because the array was changing actually. You see the array actually kind of split off here. Actually, I was taking the first and front pointer. The array was in 1 2 3 4. Array was actually 4 3 2 1, and then we didn't care about this one. The array is cut short to 4 3 2 etc. So I needed that array. So I have a check array. So what this check array does is that check array actually this portion of the code actually makes this array. It just makes this array. It just makes this array. It's actually 1 4 4. It would make this array 1 2 3 4, which is the maximum array. So why am I making this array? Is because I need to check, because I am checking based on this array. So if it is basically simple, you have to start with to add 1 to the end, then 2 here, then 3 here, then 4 here. So what I did was I put the even numbers in the first half and the odd numbers in the second half. That's how I did it. So in the case of 5, I will say 1 2 3 4 5. I have put the even numbers in the first half, and then I put the odd numbers in the second half in the reverse order. So that's how I made this array. Even numbers, and put the even numbers and odd numbers. So here what I did was I said that the count that you want was the minimum value, which is actually the minimum value plus 1. Minimum value was n minus 1. So formula's count will be having n minus 1 plus 1 n. So first of all, I am checking if c is the minimum value. If the c is the minimum value, like if c is n minus 1, then it's actually the same array itself. That is the array sorted in the ascending order 1 2 3 4. So if it is not that one, what I will do is that I will check where I will do a k. K is actually the ending pointer. That is, k is the ending pointer here, k. And then what I will do is that I will do the j is equal to k minus 1. So what is j is that j is a pointer to, if k is this one, j is the pointer to this one, 3. So why am I doing this is that it makes for easy to swap this. So I am saying that j is greater than front. So whatever is the front, the j should go from that value k minus 1 to the front value and swap each elements. Like first it should swap this 5 3, then it should swap this big element, and then it should swap this big element till the front. So it's actually following that procedure. It's actually implementation of that procedure. And then I am reversing that section. As I said, I am actually reversing this section, and then this section, and then this section, till I reach the front of whatever array. So if I reach the test case, I reach the cost already. If I reach the cost already, then I will just print the test case. Otherwise, I will increase the cost and then continue the process. And then what I'm going to do is that I'm going to say that if the front value, if the front pointer of s is same as the check array. Check array means I said that this is the check array. 2 4 is the maximum. Check array means it's the maximum value, maximum array with maximum cost. So if its front pointer coincides, then I will increment the front pointer. That is, the array size actually shortens by a 1 bit. Like I am incrementing the front portion of that, or decrementing the front portion. Like I am actually making the array shorter by removing the front element. And then we are also checking the rear case, which is the if it has of k, it's the rear case is also equal to check array. Like if the real case happens to be 1, then decrement the array. If the real case happens to be 3, then decrement the size of the array from the end, like cut short the array from the back. I mean, cut short the array from the back. So I just saved this as here. Why I saved this as? Because I am reassigning this as to array here, because here when there's a change, I am actually monitoring the change and then saving it in array. So and then actually using creating the change here again. So this was the entire program that we did. So this should work for each test cases. So the basic idea was to cut short the array and swap each individual levels. Like as I said here, what I did was first took this entire array and then took these two elements and reversed. Then these three elements and reversed. Then three elements and reversed. By that time, we have seen that one was actually fixed, and that one actually matched the size of the one actually matched the array with the largest, which is the maximum array with the maximum cost. So I cut short the array to 432 and then repeated the same exact process here for 432. So as you can see that what I did was actually this the algorithm. This could have been better done with a function, but I did it like this iteratively. This could be done better with this. What I did this iteratively. What I did this iteratively. Yeah. So this is the question. So this was actually a really interesting problem actually, because we had to reverse the first question. It was really interesting, and actually it was a lot of fun solving it. So the key element that helped me solve this first problem was I made another program to actually print the cost of 1 2 3 all permutations of 1 2 3 4. So actually I used the first program for that, and then I used a next permutation function for that, and then by looking at that function, I understood that this was the maximum. That is, if we can get the maximum by just using this 1 2 3 4. We are just actually making this pattern repeat, and this was the only maximum we had. So since I got the maximum value, I actually got the problem. That was the trick. So yeah guys, so I think you all enjoyed this problem and you understood how this problem works. I hope you understood this problem, and yeah, thank you guys, thank you for listening to this much long time to my lecture. Thank you guys, thank you so much, it really means a lot.